Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we will be discussing about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, today we are going to discuss about the projection of the oblique plane, which happens to be inclined with respect to the vertical plane and the horizontal plane. Now here we have got a hexagonal lamina having side 30 millimeter, and this hexagonal lamina is positioned in the 2D coordinate system with respect to HP and VP in such a way that this hexagonal lamina is resting on the horizontal plane on one of its edges, and while this hexagonal lamina surface it is inclined with respect to VP at an angle of 30 degree, one of the corners of the lamina, this will be resting into the VP. It will be contained by the vertical plane. So here two conditions we are required to satisfy. That is, one edge of the lamina will be resting onto the ground, and while the surface of this lamina it is inclined with respect to vertical plane at an angle of 30 degree, one of its corners will be contained by the vertical plane. So with this condition, we are required to obtain the inclination of the surface of the lamina with respect to the vertical plane. And in the second instance, the diagonal passing through that corner, which happens to lie in the vertical plane, it is further inclined at an angle of 45 degree with respect to the horizontal plane. That is, the true length of the diagonal, which is being presented onto the horizontal plane as an apparent length. So this original diagonal or the true length of the diagonal is further inclined with respect to horizontal plane at an angle of 45 degree. That is, this angle of inclination of 45 degree with respect to HP. So this angle is angle theta, whereas we will be obtaining the apparent length projection of this diagonal, because this diagonal will be inclined with respect to the vertical plane. So therefore its projection on the vertical plane will be obtained as an apparent length. So we are required to obtain the angle of inclination of this apparent length with respect to the horizontal plane. That is, angle alpha needs to be obtained in this particular case. So once we obtain the angle alpha, thereafter we will be able to obtain the orthographic projections of this hexagonal lamina. So let us first of all decide about the orientation of this particular lamina with respect to the horizontal plane and the vertical plane. So since we know that the surface of the lamina happens to be inclined with respect to VP in the first instance, so to begin with we are going to assume that this lamina will be contained by the vertical plane. So therefore the true shape of this lamina will be obtained in the front view projections, which will be obtained on the vertical plane. And while we are going to look at this particular lamina from the top view, we are going to obtain the edge view projections of this hexagonal lamina onto the horizontal plane. And since this lamina is contained by the vertical plane, so the top view, that is the edge view, will be obtained onto the XY reference line. Thereafter, once we incline the surface of this lamina with respect to the vertical plane, then one of the corners should be contained by the vertical plane, and one of the edge of this particular hexagonal lamina should also be resting onto the ground. So if we take this orientation and we incline the lamina with respect to the vertical plane, then one of the edge of the lamina will be contained by the vertical plane, and the lamina will be resting onto the ground or horizontal plane on one of its corners. So this position of the hexagonal lamina, it is inappropriate. It does not fulfill the basic conditions which are laid out or specified into this problem. Whereas if we have this particular orientation of this hexagonal lamina, then we will find that one of the edges of this hexagonal lamina, it will be resting onto the ground, and while we incline the surface of this lamina at an angle of 30 degree with respect to the vertical plane, so one of the corners of this lamina, so this will be contained by the vertical plane. So this is the appropriate or the correct orientation of the hexagonal lamina with respect to the two reference planes, that is HP and VP. Now let us proceed with the construction of the orthographic projections of this oblique lamina. Now, as we know, the true shape of this lamina will be available with us in the front view projections, which will be obtained onto the vertical plane. Now the reason is because the first angle of inclination of the surface of the lamina happens to exist with respect to the vertical plane. So to begin with, we are going to assume that this lamina, it is contained by the vertical plane, and since one of the corners will be contained by the vertical plane, so we have to assume that this is not parallel to and at a certain distance from VP, rather it is contained by the vertical plane. And another condition we have to satisfy, that is this lamina is resting on the horizontal plane over here. So it is resting on horizontal plane on one of its edges. So both the conditions, they will be satisfied over here. So this lamina, it is contained by the vertical plane. So this is the edge length, that is 30 millimeter. So with this edge length, we have drawn the true shape of this lamina as it is contained by the vertical plane. So we have got A dash, B dash, C dash, D dash, E dash and F dash as the front view projections of this lamina, which is contained by the vertical plane. Now since this lamina is contained by the vertical plane, so we have obtained the true shape in the front view. So while we look at this lamina from the top side, then we are going to view the edge view of this lamina onto the horizontal plane. So we are going to obtain the top view projections of this lamina onto the XY reference line. So here onto the XY reference line, we can check, we have been able to obtain the projections of this particular lamina. Having obtained the top view projections onto the XY reference line as an edge view, now we can join all these points in the top view. So the edge view projections of this particular hexagonal lamina have been obtained onto the horizontal plane. Now having obtained the top view projections as an edge view, now we know that the surface of this lamina, it happens to be inclined at an angle of 30 degree with respect to the vertical plane. So now this edge view will be reoriented at an angle of 30 degree with respect to the vertical plane. So we know the distances between different points which we have been able to obtain in the top view projections. Now this edge view will be reoriented at an angle of 30 degree with respect to the vertical plane in such a way that one of the corners, that is corner D, this corner, so this corner D will be contained by the vertical plane. So the end D of this particular hexagonal lamina is lying into the vertical plane. So now we have just reoriented or rotated this edge view at an angle of 30 degree. So these distances between points D and CE, similarly the distance between CE and BF, and similarly the distance between BF and A. So all these distances, they have been retained over here. Now having obtained the edge view of the inclined surface of this hexagonal lamina with respect to the vertical plane, now we are required to draw the corresponding front view projections of this particular lamina. So in order to obtain the corresponding front view projections, we are going to draw vertical projectors through each of these points which we have obtained into the plan view, and similarly the horizontal projectors we are going to draw from each of the elevation projection points which we have obtained in the previous view. And now the intersection of the corresponding points, they are going to yield the location of the corresponding points of the elevation corresponding to this inclined surface of the lamina in the front view. Now here we can see this is the vertical projector drawn through the point A1. So wherever it intersects with the horizontal projector drawn through the point A, we obtain the point A1 dash. Again, we have vertical projector drawn through the point B1, and wherever it intersects with the horizontal projector drawn through the point B dash over here. So this intersection point of these two projectors provides us with the location of the point B1 dash in the front view. Similarly, here we have point C1. So from C1 again we have drawn a vertical projector upwards, and we are going to extend this vertical projector upward till it intersects with the horizontal projector line corresponding to the point C dash over here. So this is the horizontal projector line drawn through the point C dash in the elevation view over here. So here we obtain C1 dash. Similarly, through D1 again we are going to draw a vertical projector in the upward direction, extend it in the vertical direction in such a way that it should be intersecting with the horizontal projector which has been drawn through the point D dash. So intersection of these two projectors, it has provided us with the location of the point D1 dash in the elevation. Similarly, here we have got point E1. So once we draw vertical projector through E1, we are going to extend it upwards in such a way that it should be intersecting with the horizontal projector line which has been drawn through the point E dash over here. The intersection of these two projectors will provide us with the location of the point E1 dash. And finally, through F1, we have drawn a vertical projector in the upward direction, and we will be extending it up to the point where it is going to intersect with the horizontal projector which has been drawn through the point F dash over here. So this way, the front view projections of the lamina which happens to be inclined with respect to the vertical plane at an angle of 30 degree, they have been obtained. So this is the apparent shape of the lamina which is viewed in the front view once it happens to be inclined with respect to vertical plane at an angle of 30 degree. So this shape is an apparent shape. And another thing we observe over here, that into this apparent shape, this diagonal A1 dash D1 dash is there, which is passing through the point D1 dash which is contained by the vertical plane. So we can see point D is contained by the vertical plane. So since point D1, it lies in the vertical plane, therefore the diagonal passing through D1 dash happens to be A1 dash D1 dash. But because of the inclination of this diagonal with respect to vertical plane, in the front view, this diagonal is being viewed as or represented as an apparent length. But we have been provided with this information that the original diagonal, that is the true length of the diagonal passing through the corner which is lying in the vertical plane. So this true length of the diagonal AD, it is inclined at an angle of 45 degree with respect to the horizontal plane. So whereas in this view we are able to see only the apparent length, where we can view the true length of this diagonal, we can see that A1 dash D1 dash happens to be parallel to the horizontal plane. So therefore A1 D1 will be the true length of this diagonal. So this is the true length. Or even in the first view also, D dash A dash was the true length of this diagonal. So this is the true length of the diagonal which is available as an edge view over here, when we had assumed that this hexagonal lamina is contained by the vertical plane. Similarly, we had transferred this edge view over here. So this edge view A1 D1 in the top view will be representing the true length of this diagonal over here. So now we know the angle theta. So angle theta means it is the angle of inclination of the true length of an edge. Edge means a diagonal DA. It happens to be inclined with respect to the horizontal plane at an angle of 45 degree. Now we can mark 2 points over here alongside this orientation line which we have drawn at an angle of theta is equal to 45. Why I am repeatedly saying theta? So theta is the angle of inclination of the true length of a line. So true length of the line means true length of the diagonal AD. So this diagonal will be represented as D2 dash and A21 dash. So this is the true length of the diagonal which is equal to either you can say D1 A1 or this is equal to DA or this is equal to D dash A dash. So thrice it has been represented over here. So this length we are going to mark it over here. This is the true length of the diagonal DA. Now having obtained the true length of the diagonal inclined at an angle of theta is equal to 45. Now the actual angle of inclination of this apparent length with respect to the horizontal plane needs to be evaluated. So the apparent length is inclined with respect to horizontal plane at an angle alpha. So using the principles of rotation of the line method, so we know that the true length and the apparent length, they will be both marked between two locus lines, and between these two locus lines, that is this locus line and this locus line. So this is our true length, whereas this is our apparent length. Now this, how much is this apparent length that we have marked over here? It is equal to D1 dash and A1 dash. So we are going to measure this apparent length distance of the projector which is going to connect points D1 dash and A1 dash. So this is the length of the diagonal AD as viewed in the front view projections over here. Now after measuring this length D1 dash A1 dash, so that apparent length we have connected over here. Now once we obtain this apparent length between these two locus lines, now we are able to obtain the angle alpha over here. So you can see angle alpha, it will be greater than the angle theta, that is the apparent angle of inclination of a line. It happens to be bigger than or greater than the true angle of inclination of the line, whereas vice versa will be true for the lengths. True length of a line will be greater than apparent length of a line. So we can see true length of the diagonal AD, that is D2 dash and A21 dash. So this happens to be greater than apparent length projection, that is D2 dash and A2 dash. So the angle of inclination of this apparent length has been obtained as 49 degree over here. Now having obtained this actual angle of inclination of the apparent length of the diagonal passing through the point D with respect to the horizontal plane, now we need to transfer this apparent shape of the hexagon over here in such a way that this diagonal distance D1 dash A1 dash, so it should be lying over here, and this hexagonal apparent shape figure that we have obtained as a front view projections in the previous view, so this hexagonal apparent shape has to be transferred or rotated across this particular apparent length orientation over here, which is inclined at an angle of 49 degree. So how we can transfer it? Now we can inscribe this apparent shape of the hexagonal front view projections into a rectangular figure. Please see, this is a rectangular figure, and this rectangular figure we can further divide it into two halves, because this is the diagonal part. One half of the rectangle will be lying on this side, another half of the rectangle will be lying on this side. So first of all, let me draw this diagonal. You can see we have drawn this diagonal over here. Half of the rectangle, it lies above this diagonal over here, D2 dash A2 dash, and the remainder half of the rectangular construction, it is lying below this diagonal, that is D2 dash A2 dash. Now we know the distance between this edge and point F1 dash and B1 dash. We also know the distance between this edge of the rectangle and the points E1 dash and C1 dash. So this distance and this distance we know. So accordingly we have marked this distance over here and this distance over here. 2 points we have already located corresponding to this apparent shape of the hexagonal lamina in the front view. So first 2 points we have already obtained. Another 4 points we have obtained by virtue of locating this distance and this distance. At this distance from this edge, 2 points F1 dash and B1 dash will be located at the two extremes of this particular projection line. Similarly, at this distance, we are going to locate points E1 dash and C1 dash on the two extremes of this particular projection which we have drawn over here. So here we can see another 4 points we have been able to mark over here. So now we can transfer this hexagonal apparent shape into the front view projections over here. So now we have been able to obtain the apparent shape projections of this oblique lamina. These front view projections have been drawn when the lamina happened to be inclined with respect to the vertical plane at an angle of 30 degree, and the apparent length of the diagonal passing through the point D, it happens to be inclined with respect to the horizontal plane at an angle alpha is equal to 49 degree. So this way, these are the front view projections of the oblique lamina. Now, having obtained the front view projections of the oblique lamina, now we are going to work out the corresponding projections of this oblique lamina in the top view. Wherever the vertical projectors drawn through the front view elevation projection points, they intersect with the horizontal projections which have been obtained through these plan projection points. So we are going to obtain the location of all the edges of this particular hexagon in the top view. Now we can see we have drawn a vertical projector line through the point A2 dash in the front view. So this vertical projector will be extended into the top view projections till it intersects with the horizontal projector line which has been drawn through the point A1 over here. So this intersection of these two mutually perpendicular projection lines, they will be providing us with the location of the point A2. Similarly, from B2 dash, we have drawn a vertical projector downwards and extended it up to the limit where it is going to intersect with the horizontal projector which has been drawn through the point B1 of the top view. Similarly, you have got point C2 to be obtained. So from C2 dash, we are going to draw a vertical projector in the downward direction and extend it up to the limit where it is going to intersect with the horizontal projector drawn through the point C from the previous view. So this intersection of these two projectors will provide us with the location of the point C2 in the top view. Similarly, you have got point D2 dash located over here in the front view. From D2 dash, we have drawn a vertical projector downwards and extended it up to the limit where it is going to intersect with the horizontal projector which has been drawn through the point D1 of the plan projector view which we had drawn previously. And we have got point E2 dash over here. Again, from E2 dash, we are going to draw a vertical projector in the downward direction and we extend it up to the limit where it is going to intersect with the horizontal projector which has been drawn through the point E1 of the plan. So this intersection of these two projectors, so they will provide us with the location of the point E2. And finally, from point F2 dash, again we have drawn a vertical projector in the downward direction and we have extended it up to the limit where it is going to intersect with horizontal projector which has been drawn through the point F1, that is corresponding to the plan projection point which we have already obtained. So this way the top view projections of this oblique hexagonal lamina, they have been obtained, and once we join all of these points A2, B2, C2, D2, E2 and F2, so we have been able to obtain the top view projections of this oblique lamina. So here we have got the front view projections of this oblique lamina over here. Here we have got the top view projections of this oblique lamina which have been drawn corresponding to the inclination of this lamina at an angle of 30 degree with respect to the vertical plane, and they have been drawn corresponding to the angle of inclination, that is angle alpha of 49 degree with respect to the horizontal plane. So this is all for today. So I hope that through this discussion, you would have understood about the procedure to evaluate the orthographic projections of the oblique hexagonal lamina, which happens to be inclined with respect to the vertical plane as well as with respect to the horizontal plane. So we will be continuing with further discussion regarding few more illustrative cases of projections of the planes in the coming lectures as well. So thank you very much. Thanks a lot.